Okay, let's take a few minutes to talk about capacitors in series. Really only a small part of the AP test, but important to get everything you can get. Now, key thing to understand with capacitors, again, is they're the opposites of resistors. And since we spent a lot of time with resistors talking about them, remember that right there, because that will go a long way to helping you learn. So we'll just put that over there on the side so it can help us. Okay, now let's take a look at capacitors in series. So I have a battery, positive, negative. I come out of here. I go to one plate of a capacitor. So what I have is two capacitors. We'll call that capacitor 1. We'll call that capacitor 2. Now, down here I have a certain voltage. Now, the key thing I think to understand this is that the middle wire, this wire right here, is not physically connected to the circuit. So what's going to happen is it makes sense that I'm going to get a buildup of positive charges over here, and I'm going to get a buildup of negative charges over here. That makes sense. Well, what's going to happen since this has since you have a positive charge right here, this particular plate is going to become negative. Since you have a negative charge right here, this particular plate is going to become positive. Now, here's the key thing to help you understand this. Since this piece of wire is not connected, remember it's separated by a dielectric there and separated by a dielectric there. Since that's not connected, that Q and that Q have to be the same. Essentially, all you've done in that piece of wire right there is transfer electrons. We've had electrons go to this end, so it becomes negative. This end lost the same number of electrons, so it's positive. So the key thing to understand is Q is the same. Q, same. Key thing to understand capacitors in series. The charge on those two in series is going to be the same. So once you realize that Q stays the same, and you need to keep that in your brain bone somewhere, Q has to stay the same. And you can actually do the same analogy we just did and figuring out right at the time being you need to figure it out. Now, let's take a look at my voltage. I have a voltage total there. My voltage total is going to equal V1 plus V2, where V1 would be the voltage across this one, V2 would be the voltage across this one. Now, those are going to be different because the capacitors are different. So let's make sure we understand that. So what I'm going to say is V total. Now, I'm going to go to my basic equation. C is equal to Q over V. So therefore, I'm going to say V is equal to Q divided by C. Done a little math there just to rearrange it. So what I'm going to say now is Q total over C total is equal to Q1 over C1 plus Q2 divided by C2. Now here's the nice thing when I take a look at that equation, because the Q's are the same. So therefore I can get rid of them. So 1 over C total is equal to 1 over C1 plus 1 over C2. That's the opposite of what we do with resistors. Remember, with resistors in series, we add them up. For capacitors in series, we add up the reciprocals. They're simply opposites of each other. And again, if you can remember that, that'll go a long way to helping you to do it. So the key thing, let's sum it all up on one slide. Okay, let's sum it up for a C in series. So we're talking about series Cs. Key thing to understand is Q is going to be the same. Q is the same. The voltages are different. So in a series circuit, although the charge on each one of them is the same, the voltages are going to be different. That is similar to what we see with resistors in series. The fact that the voltages are different. The voltages are different are what allows it to do it. So for capacitors in series, I add reciprocals. Part they like the best? This. Q is the same. And I might circle that 1,000 times. Q is the same. And let's go to there. And V's are different. Hope this helped.